झालं आहे मॅडम.
Over to Chapter. A very good morning to all of you. Today's lecture is scheduled on the topic Space Infrastructure and Data Products for Meteorological Studies, and it will be delivered by Dr. C.M. Kishtawal, former outstanding scientist, Space Application Center, ISRO, Ahmedabad. A very warm welcome to you, sir. And thank you, sir, for taking your time for delivering this lecture to our specially designed course for school teachers. We also have with us Head GITDL, Dr. Harish Karnatak, and other colleagues from IIRS. I welcome you all. And this lecture is scheduled for 40 minutes. And before we start the lecture, I would like to apprise the audience about the contribution of Dr. C.M. Kishtawal sir to the field of satellite meteorology. It gives me immense pleasure to read the biodata of Dr. C.M. Kishtawal sir. However, sir's contribution is enormous to the field of satellite meteorology, but due to time constraint, I will read it in short. Sir has served ISRO in the capacity of scientist for more than 3 decades. He was an outstanding scientist and group director at the Space Application Center and received his master's degree in physics with specialization in astrophysics from Kumayu University, Nainital in 1984. He joined ISRO in 1984 and completed his PhD from Indian Institute of Technology, Delhi in 1994. His research interests include the development of techniques for operational prediction of tropical cyclones using satellite observations, monsoon prediction, operational retrieval of cloud motion winds from satellite observations, and impact of land surface processes on weather and climate, particularly the impact of agricultural intensification and urbanization. During the year 1998 and 1999, he was research associate in Florida State University, USA, where he worked towards the development of multimodal ensemble techniques for improvement of weather prediction on medium range to
all of you. I have a great respect for the teachers, and also I compliment IIRS Dehradun for conducting this kind of course for the teachers, and I think this is one of the very good initiative. So with this, I just will begin my talk, and sorry. Okay, so I'm doing my full screen. So can you see my screen, please?
Yes, sir.
Okay, thank you very much. So I'll do full screen. My talk is actually very, very simple. I put it in a very simple language, so you'll all be able to understand that. So my talk is about the weather satellites, and all this satellite needs actually start with the weather. So nowadays, actually, the importance of weather, everybody understands, everybody knows. No activity of our society can be completed without the information of the weather. Weather forecasting plays a very major role in many places. For example, I start with the aviation. Actually, aviation, like the flights, etc., they depend a lot on the weather forecasting support, and it cannot move without the weather forecasting, because the taking off and the landing of the aircrafts critically depends upon the weather situations, and sometimes it becomes normally it does not create a problem, but when it creates the problem, it becomes a big problem for aircraft industry. So weather information, how the weather is going to move, is very, very important. It is very important for the agriculture, actually. So all the food production, they critically depend upon how the temperature will vary, what will be the maximum temperature, what will be the minimum temperature, because the agriculture is one industry where all their assets are exposed under the sky. So anytime one big event can spoil everything. And not only that, that is one extreme event I'm talking. The crop growth, how much will be the yield, it depends a lot upon how much will be the rain and how much will be the temperature variations. So all these things the farmers community need to know, and there is a big impact actually. I think if they know the weather very properly and very precisely, they can increase their profits by around 20%, which is quite a big amount. Then similarly, you can see that the tourism industry, sports industry, even the shopping malls depend a lot. For example, the monsoon season is starting in India. So shopping, the mall people want to know that what kind of rain it will be. Will it rain very heavily? So they will stock the rainy items like the umbrellas and the raincoats, etc. And it costs a lot because they have to make inventory of all these articles and they have to store those items into their stores. And if it does not rain, then all this exercise goes waste. So they have to know very clearly that what kind of weather it is going to be, so that what kind of demand will be there in the market for different kind of communities, different kind of commodities. So this makes a lot of business sense, and they can make a lot of profit, or they can make a lot of loss with or without the proper information of weather. Similarly, you know that there are some extreme weathers like tropical cyclones and the flash floods, even droughts. They people can do advanced planning if they know that what kind of weather they are going to face. So there are a number of things. Even we are from the ISRO community, which is basically has a very big presence in the launch market. And for the rocket launches, the weather plays a very, very important role. For example, there are a number of operations. For example, when you fill the fuel into the rockets, it's basically it is a cold, very, very cold cryogenic fuel. It is a minus 200, minus 250 degrees centigrade temperature. So a small amount of like a lightning can spoil this whole thing, all the filling operations. Similarly, when the vehicles move from their spot to the launch pad, so even a small amount of wind can create a lot of problem. While at the time of launching, the convective weather, like the very cloudy weather, lightning, etc., they can spoil the whole launch exercise. So this is very important. Then nowadays people are very much bothered about the air quality. Then the heat waves is becoming a big problem nowadays. The heat waves and some of the states of India, and particularly I think in the Africa and other places like Oman and Asia, other regions of the Asia, I think heat wave is becoming a big problem these days, and it is a big health problem because then people they're exposed to the heat, and then there are a lot of health issues, particularly to the elderly people. This heat wave and heat strokes are becoming a big problem these days, and scientists have predicted that these kind of events may increase in the future. So all these things has to be advanced warning, and then nowadays there are a lot of stress on the solar energy, wind energy.
On medium range to seasonal time scale. During 2009 to 2010, he was a visiting scientist at Purdue University, USA, where he worked on operational and theoretical aspects of land surface atmosphere interaction processes. There are various awards to Sir's credit, and he has 170 peer-reviewed research publications in various scientific journals to his credit. Now, I request Dr. C.M. Kishtawal sir to start the lecture, please.
Okay. Thank you. Charu, thank you, Dr. Charu, Dr. Harish. So indebted and so feel overwhelmed that for giving me this opportunity. And this opportunity is unique for me because I'm interacting with one of the most privileged communities. Of the society, that is teachers, because teachers continue contribution in our life is very immense, and I still remember some of my very great teachers which shaped my career and my education. So I salute all of you. I have a great respect for the teachers, and also I compliment IIRS Dehradun for conducting this kind of course for the teachers, and I think this is one of the very good initiative. So with this, I just will begin my talk. And sorry. Okay. So I'm doing my full screen. So can you see my screen, please?
Yes, yes, sir.
Okay, thank
Yes,
you.
I
Thank
can
you very
see,
much. So thank you. So I'll do full screen this. And my talk is actually very, very simple. I put it in a very simple language. So you'll all be able to understand that. So my talk is about the weather satellites and all this satellite needs actually start with the weather. So nowadays, actually, fill the fuel into the rocket around $200 billion, and droughts cost $34 billion. $3 billion is the cost of heat waves, the total loss incurred by due to that. So weather forecasting actually makes a lot of economic sense also. So if you can predict the weather properly, we cannot prevent all the losses, but I think around 20% losses can be prevented with the proper warning and the proper predictions. And you can see that the tropical cyclone is one big problem. Not problem. Actually, this is a sign of the climate change. And particularly the people who are living in the Oman, they may be knowing that the tropical cyclones are reaching up to Oman nowadays also. So in 20 years back, the tropical cyclones are not reaching up to Oman. So but nowadays at least one cyclone regularly comes to the Oman coast, and the Arabian Sea is very active these days. So in the last 10 years, we are seeing that the Arabian Sea activities are increasing a lot, and this is also a sign of the climate change. And we have to not only predict, we have to also understand that why these tropical cyclones are increasing, what is happening to the climate change, and what will happen if these tropical cyclones increase in the future. So, for example, this is one of the examples of the tropical cyclones, and this is one of the very unprecedented kind of tropical cyclone that hit the Gujarat coast where I live, and there was a widespread damage by this tropical cyclone, and people have studied that these tropical cyclones are increasing in intensity, and this tropical cyclone had an impact up to 2,000 kilometers. So it went all the way from the west coast of India and then all the way up to Himalayas. So even in the Himalayas, people experience a lot of rainfall due to this tropical weather system. So these kind of systems are becoming more and more prominent and more frequent these days, and which makes the study of these events and the observation of these events very critical matter. Similarly, the floods. Nowadays, you know that the flood is number one hazard, meteorological hazard, because tropical cyclones, you know the tropical cyclone is coming. You know 5 days in advance that the tropical cyclone is coming to Oman or tropical cyclone is coming to India. We know very well. And nowadays, the weather forecasting has improved so much that we know 5 days in advance that exactly where it's going to hit. So people make advanced preparations, and nowadays people don't die because of the tropical cyclones much. There is a lot of property damage, but personal loss of life has been minimized because of the tropical cyclones, because we know that tropical cyclones very well. The flash floods is one thing that is still, the prediction of flash floods is still not very accurate because they come very suddenly. In the morning, you don't know that in the daytime a flood is going to come. So they develop very suddenly, and then they create a lot of havoc, and then after that they leave a trail of destruction behind them. So nowadays, these floods have become a number one calamity, meteorological calamity, and it is a challenge to predict these floods and this kind of heavy rainfall events, sudden rainfall events, very precisely. And this is one of the challenges. So how actually we do all these things, and how the prediction business actually comes into picture, and how we are able to predict it. So basically, every scientific study basically starts with good observation. So there are three processes, as you are teachers and you all know very well, that we basically there are three processes. Basically, first we have to observe some certain things, then we have to understand it. First we observe, then we understand, and then based on that understanding, we make. So you want me to reply these questions, Dr. Harish?
No, sir. Not live. Okay, just sir.
Okay.
You please go.
Okay. So at the end of the yes, we'll do that. So first we observe, then we understand, and then we predict the weather. So everything, not only weather, everything in the science, like even in the chemical reactions, we are able to predict because we understand about it. How we understand? Because we have observed this phenomena very clearly. So first thing is the observation. So the first thing in this thing is the correct observations. Everything starts with observation, a good observation. So that is what is my today's talk is totally devoted. So how we observe the weather? So the first most basic thing in the weather observation is basically the conventional surface meteorological observations, observatories. This is a very simple instrument. You can see that there are the winds. There is some wind vane, that is wind is blowing, and there are some instruments. You can see this. This instrument is basically, this instrument measures the temperature. Then some instrument measures the radiation. Some instrument measures the rainfall. This is the small rain gauge instrument. And all these instruments is small weather observatories. And this is the very simplest of the weather observing system. And this is not only, it is only simple, but it is very important part of the entire weather observation system. So how much these observations are? Basically, these observations are approximately 10,000 such observatories are there, which are managed by the governments. And you can see the big problem is there. You can see the parts of the Africa, whereas we are having a lot of African deserts. So these deserts are, and a lot of parts of the Himalayas and deserts and some parts of the South America and lots of parts of the ocean. It is not covered by this kind of instruments because it is very difficult to, they are basically manually they have to be done, and we are not able to keep them manually. They have to be, not only they have to be kept there, they have to be maintained also. Their battery has to be replaced, their instrument has to be monitored all the time. So it is not easy to do. For example, in the Greenland, you can see there is, inside the Greenland there is only one observatory. In the Canada there are very few. In the Africa there are very few. In India, but in the Europe and in America you can see a big density of all those things. Even in the desert part of the Australia, you see that even though Australia is quite a good developed country, rich country, but you can see that there are not many such observatories inside the Australia. So I want to say that it is difficult to maintain this kind of manual observatories. And they are only 10,000. But nowadays, lots of people are coming. There is a lot of interest in the weather forecasting. So a lot of private people have come up with their own observatories. They are very cheap instruments. They are available in less than $300. To you can buy this kind of instrument in less than $300. So lots of private people are buying this kind of things, and you can see in the Europe and in the America and parts of the South Africa, Australia, in Japan, several private people have bought this kind of weather station, and private weather stations are much more than the government weather stations. They are approximately 250,000. It is, I think, 25 times bigger infrastructure than the government ones. And they are quite good maintained, and but this data is not available to everybody. So that is one problem. Now the problem is that the weather is not limited to the only surface. The weather is three-dimensional. So we are having the weather in the upper air also. Even though we don't bother much about what is happening at 10-kilometer height or what is happening at the 2-kilometer height, we are mostly worried what is happening at the surface because we live in the surface. But actually, what is happening at 10-kilometer height or 6-kilometer height, it affects our surface weather also. So it is very important to know what is happening at the upper air, what is happening in the three-dimensional weather, three-dimensional atmosphere. So for that, there are different kind of instruments, what is called the weather balloons, and they are controlled by the GPS. They are fitted with the GPS, so we know exactly where they are moving. So they are actually launched every some centers launch it 2 times a day, some centers launch it 1 time a day. But there are approximately 1,000 such stations, and they give us very important information. So what is happening at the 1 kilometer or 2 kilometer? This I have shown in this kind of a three-dimensional layer. So in the lower part we are having a very hot temperature, but as you go up, it is very cold temperature, and this difference actually creates a lot of weather. So when it is a lot of warming and lot of wet weather, lot of humidity in the surface, and then we are having very cold weather in the top, then this is the indicator of the very, very convective weather, like thunderstorms and very big kind of heavy floods kind of situation is occurring. So it's very important to know what is the weather and what is the how is the weather in the upper atmosphere. It is very, very important observation. So you know that similar to the surface of we are having approximately 1,000 upper air observations, and not many private players are in this business. So these are mostly maintained by the government agencies, and 1,000 you can see again there are a lot of gaps even in India and a lot of part of Canada, Africa, etc. So we are not having many surface observations. They are mostly confined to the land and some island stations, ships also. So yes, whatever you are seeing in the ocean, it is basically they are launched from the ship. So they are 1,000. So you can see this by seeing this picture that it is not enough. These observations are not enough to fill the entire Earth, because we cannot ignore what is happening over the ocean, because ultimately the ocean weather is coming to an end, and then it is creating the weather in our city. So we have to know that what is happening at the oceans also. So for that, actually one of the very important observations I forgot to mention, it is coming from the aircrafts. So all the commercial aircrafts are actually fitted with the weather measurement instruments. So when an aircraft is taking off, so it is every 1 second or every 2 seconds, it is measuring those observations. It is measuring the temperature, it is measuring the wind, pressure, humidity, etc. And it is one of the most valuable observations actually, because the aircraft is physically measuring them. It is actually measuring them. So we are it is not that something we are doing by the remote sensing. It is actually aircraft is taking off, and all the upper air observations it is taking. So this is one of the very accurate and one of the very, very valuable observation. But you can see that because of the COVID situation and the lockdown situation, and international flights are not going up. So you can see that what is the situation? What was the situation in 2020, in 2019, and what is the situation in 2020? So there is a lot of difference in this observation. These observations are not getting available nowadays because flights have they have reduced their operation, and this data was going into the weather forecasting models. So this kind of lockdown situation has also affected the weather forecasting accuracies also, because this data is not going. So weather forecasting models are not knowing what is happening at the upper air. They are not knowing good enough. So it is also affecting the forecasting capabilities. So this I wanted to show, to tell you that how these observations are very important for making the predictions also. Similarly, we are also having a lot of oceans are covered, but they are giving us the oceanic observations, like the sea surface temperature, the deep ocean temperatures, the deep ocean pressure, deep ocean salinity. Mostly they are not giving the atmospheric observations. They are the oceanic buoys, and they are mostly focused on taking the oceanic measurements. But it is nonetheless a very, very important observation. So basically, by the previous examples, it is clear that now we need some observation which can cover the entire Earth, including the oceans, and which can give us the day and night surveys, and we can get the total observations all the time under all the conditions. So what kind of observation instrument this can be? So only one thing comes to our mind, that is satellite. The satellite is the only instrument that can give you global coverage by a single instrument. So that is why satellites have become a very, very important, necessary part of the weather forecasting services. So what is the advantage of satellite observation? The number one advantage is the coverage. The satellites can give you the amount of coverage that one ground-based instrument can never give. Similarly, the satellites can give you the repeativity. So it can give you you can see in the second diagram that some satellite is repeatedly giving the observation. So, for example, nowadays weather satellites can give you the weather observation at every 10-minute interval, every 15-minute interval. So this is unprecedented. Every 15 minutes you can update what is happening in our surroundings and what is happening in our area. So this is very important to monitor the weather. If there is a thunderstorm is developing some 100 kilometers from my city, so if I can monitor it every 10 minutes or every 15 minutes, we can very quickly know that how fast it is moving towards our city, and very advanced warning can be given. And lots of measures can be taken, like the traffic can be stopped, or maybe the people can be told to evacuate, the schools can be told to shut down, and then the children can be taken to the safety. So this is very, very important to the nowcasting and the forecasting of the weather. And the third important advantage is the representativeness. What is representative observation means? As I showed in the previous pictures, that there are thousands of instruments which have been installed by different government offices. But each instrument is separate. So if one instrument goes wrong, we never know that this instrument has gone wrong and this is giving wrong observations. But in the satellite, what happens that this is one instrument which is measuring everything. In one satellite, this is one instrument that is measuring the entire Earth. So if something is wrong, then we have to correct that instrument only. Then all the observations will be corrected automatically. So that is called the representative observation. It means all the observations are taken by one single instrument. That is a big advantage. So Because of that, historically, in 1960, April 1, the first weather satellite was launched, and that is called the TIROS 1. So basically, it was the television infrared operational satellite. So it gave us the pictures only. It did not give us any digital data. It was not a digital picture. So nowadays, even a mobile camera has a digital pictures, but this satellite is quite a big satellite, but it gave us only the analog pictures, not the data, only pictures. But those pictures were very valuable because those pictures told us that weather is not confined to one country. Weather is universal. Actually, it is global. So, what weather is coming to India? Basically, it comes from other countries. It comes from Bangladesh. It comes from Pakistan. It comes from Russia. So, without understanding the weather of Russia or weather of Pakistan, I cannot predict the weather of India. So, the weather of India cannot be predicted by observation taken over India, or weather of Oman cannot be predicted by if you take only observation from Oman. So you need some platform where you can take the global observations, and that is for that the satellites are the most important tool and most important observation. And since that time in 1960, these observations have gradually improved over the time, and they have become more and more sophisticated. So initially we had only the TIROS analog pictures. Now, then there was a time in 1970s, by 70s, people were working on the digital type of pictures where they can analyze those pictures, they can use those pictures in their mathematical models. Then slowly, initially people were working with the infrared visible kind of things only. Then they slowly went to the microwave frequencies. Then they went to the active radar. They installed radars in the satellite systems. So nowadays satellites are having many radars on their in their instrument list. So they provided us lots of other observations like the ocean surface winds, etc., and the precipitation profiles. Then they went to the hyperspectral. So hyperspectral means nowadays the satellites are having thousands of channels. They are having pictures taken in thousands of bands. So when they take a picture, there are at least 8,000 pictures they are taking at the same time. So with this kind of hyperspectral imaging, what happens that they are able to tell a lot of things about the weather and the clouds. So, and then I'll cover these things in my subsequent slides. And recently, in 2020 or 2019, there is a very powerful laser has been put in the orbit, and which is measuring the movements of the aerosols and the molecules of the air, and indirectly or directly it is measuring the winds, how much wind is blowing in the atmosphere. So this is how much wind is blowing and at what level it's blowing. So that is the latest development that is in the atmospheric sciences, in the meteorological satellites. It is a very powerful laser we are having nowadays, and it is giving us the very variable observations of the vertical structure of the wind. So these are the instrument. This picture shows that how the satellite instruments have progressed over the period of time, and it is lots of new things are happening, some of which I will try to cover in my slides. So basically, how the satellites take the observation. This is one of the most popular orbits of the satellites. So you know the satellites, once you launch a satellite, the satellite will go into some orbit. So orbit means how it rotates around the Earth. So it can rotate from this to this side also. This is called the polar orbiting satellite. But this satellite is having a very special significance. What is the relevance of this orbit is that it rotates with the same speed when this rotates with the same orbital speed as the Earth. So what is the advantage of that? When the satellite rotates like this, then the Earth looks stationary to that. So that is why these orbits are called geostationary orbits. So geostationary means with respect to this satellite, the Earth looks stationary. So what is the advantage of that? So this particular satellite is the example. In this example, the satellite is situated over the south is the America. So for the American persons, this satellite is stationary, and for this satellite, all this whole part of this America is stationary. So it means whatever is weather is taking place over there, whatever clouds are moving, it does not matter that whether Earth is moving or not, because it tracks only the movement of clouds. It does not track the movement of the Earth. So that is the big advantage. So Earth looks very stationary with respect to this kind of satellite orbits. Now, there is one big disadvantage of this orbit is that this is in the equatorial plane. So some angles become very unfavorable. So some high latitudes like Russia and South Africa, etc., they are not very clearly visible with this kind of angle. So it can see only the plus minus 50 from any part. So this is the inside 3D, for example. It can look only plus 50 degree and minus 50 degree. So it can look only a small part of the Earth. It cannot look entire Earth because the upper part becomes very, very blurred, and the resolution of and the clarity of those pixels are not very good. So for that, there is some other orbits people have thought of, like the polar orbits. So what polar orbit does is it goes pole to pole. So when it goes pole to pole, it takes the measurement from a very nearby surface, from very near to the Earth. It is this kind of satellites are hardly 800 kilometers from the Earth, while the geostationary satellites are 36,000 kilometers from the Earth. So in this, what happens? This satellite is going from pole to pole. In the same time, the Earth is moving from west to east. So satellite goes. So when satellite comes next time, satellite sees in a different part of the Earth. So as a result, in one day, the satellite scans the entire Earth. But the disadvantage is that at one time it sees only one small part of the Earth actually. But in one day it sees the entire part of the entire Earth, while the geostationary satellites will look at only one face of the Earth. So that is the one disadvantage and advantage of these two different orbits. Now, what happens that because of the geostationary kind of things, the upper latitude, the people living in the upper latitudes, in the higher latitudes, they are in disadvantage. So what they have done, they have